Good morning. Today we will go to second class of magnetism, and in the last class we have studied about paramagnetism. So now we learn about diamagnetism. Okay, diamantism and ferromagnetism. Now let us see what is diamantism is and what are diamagnetic materials. Okay, now the substances which when placed in a magnetizing field get feebly magnetized in a direction opposite to this magnetizing field are called diamagnetic. Magnetizing field means the external field that we apply. Feebly means weakly, that is not strong. Okay, so I can define a diamagnetic material as those substances which when placed in a magnetizing field gets weakly magnetized or feebly magnetized in a direction opposite to that of the magnetizing field. Okay, now examples are bismuth, copper, silver, mercury, lead, water, alcohol, hydrogen and inert gases like helium, neon, etc. Now the first property is similar to that of the definition, that is when a diamagnetic material is placed in a magnetizing field, it will get magnetized. How it is magnetized is getting feebly magnetized in a direction opposite to that of the magnetizing field. Now, when it is placed in a non-uniform field, that is when a diamagnetic material is subjected to a non-uniform field, it will always have a tendency to move from strong field to weak field. See, here you can see a U-tube that is filled with a diamagnetic liquid, and in one of the limb we are applying a strong field, that is it is placed between the poles of a strong magnet, whereas the other limb is let free. So what happens is that this diamagnetic liquid will move from the region of strong field to the region of low field. Okay, which is that's the opposite of that of a paramagnetic material. Okay, now a diamagnetic, when a diamagnetic rod is suspended in a uniform magnetic field, what happens to it? It aligns in a direction perpendicular to the field direction. Now next is the susceptibility chi given by I by H. I is intensity of magnetization and H is a magnetizing field. Its value is very small and negative, and it is a constant and does not vary with field or temperature. The only exception is bismuth. Now relative permeability mu r is always less than 1. Now what's the cause of diamantism? Diamantism, the main cause is due to the spin motion of electrons. We know electrons are charged particles that revolve around the nucleus, and since they are revolving charged particles, it can be considered as a current, and each of these electrons will process a magnetic moment, and the atom will have several such electrons, and each of these electrons will have magnetic moment, but the net magnetic dipole moment will be 0. So when a field is applied, or when we are applying a magnetic field externally in a direction normal to the orbit, then the net dipole moment is not 0. Instead, the direction, it will have a dipole moment and its direction will be opposite to that of the applied field. So this diamagnetic susceptibility, as we already said, chi is always negative. Now ferromagnetism means such substances when placed in a magnetic field get strongly magnetized. In the diamagnetic case it is feebly magnetized. Here the direction of magnetization is in the same direction as that of the applied field, whereas in diamagnetic case it is opposite to that of the applied field. So ferromagnetic substances are those substances which when placed in a magnetic field get strongly magnetized in a direction similar to that of the applied field. That itself is the first property, and its examples are iron, cobalt, nickel, and their alloys. Okay, now here you can see a graph that is the intensity of magnetization I versus H, or the magnetizing field. Now this I is very large positive and varies non-linearly, that is the variation is not linear, it is non-linear variation. Okay, and the upper limit is called saturation magnetization, and it depends on nature of material. Now in this case susceptibility, that is chi m, is very large, of the order of 10 raised to 3 to 10 raised to 5, and it varies with temperature in a complex way. And so for temperature, that is tau greater than theta c, that is Curie temperature, theta c is called Curie temperature, then the susceptibility chi m is proportional to 1 minus tau minus theta c, and this is called Curie law, where theta c is a constant and depends on nature of material. It is called by the name Curie temperature. Okay, so Curie temperature is a temperature above which a ferromagnetic material behaves like a paramagnetic material, and this is graph is that of iron. Okay, now in this case the relative permeability is very large, and it also varies linearly, non-linearly with magnetizing field as shown in the figure. Large value of mu r means that the field inside the material is stronger than the magnetizing field. Now the only cause for ferromagnetism is due to the spin-spin interaction of electrons. That is, electrons have got spin motion, and so spin motion of one electron, when it interacts with the spin motion of the other electron, this give rise to ferromagnetism. Now this is just a comparison chart between diamantism, paramagnetism and ferromagnetism. So this particular table is very very important because it has summarized all the properties that we have studied earlier. So please try to learn this table. Here there are total 9 properties. I am not explaining it again because this we have already explained in each of these sessions, namely diamantism, paramagnetism and ferromagnetism. So this is just a summary. So learn this table very well. Okay, in the last, please don't forget to write the examples. That's ninth one is actually the examples for each of these magnetisms. Okay, so study well this table. Okay, that's it for now. Thank you.